Yeah. So now the presentation will be given by Dr. Zotali. He will give talk on the data protection and privacy consideration for digitally captured signature collection within a forensic laboratory.
Yes,
Yeah.
this is me.
So we will be discussing the intricacies and the implications of using and accessing digitally captured signatures within a forensic environment from a data protection and a legal perspective, because inevitably that comes into play. So first of all, to touch base with the nature of the biometric data, as we briefly introduced yesterday as well, digitally captured signatures means biometric data in the form of X, Y, F, and time, which are numerical data. That is the core of the digitally captured signature, and that is by definition the biometric data that we are accessing. We have to take into account the difference in the medium when compared to traditional pen and paper documents. In the pen and paper world, when we have a document, the document itself contains the signature or the handwriting that we are asked to examine. And by itself, it's a unique original, which means when the expert has access to the original, they can perform all necessary examinations and so on. This triviality, let's say, of the different aspects of the examination that exist in the pen and paper world cannot be transferred in the digital world. In the digital world, when a person, a writer, or a customer in a bank executes a signature with the appropriate software and hardware solution, their stylus movement during the execution of the signature is being encoded, and it is being encrypted in a digital container file. The next step is to be able to access the biometric data, which means decryption of the container file and access and extraction of that biometric data from the encrypted container file. And the third step is the analysis of the biometric data by the expert, which can include another step in the process required for the extracted data to be handled properly, to be made compatible, and even to be normalized in order to be imported to the analysis software that we are using, and therefore be able to perform the actual analysis. So we can see that the intricacies of this structure means that we lose the uniqueness of the document. In this setup, the digital container file can be copied accurately, and it will still contain the biometric data. And the biometric data themselves can be extracted and removed and separated from the original container file. So we need to readjust our terminology and move from the uniqueness or from the originality in the pen and paper world to the integrity in the digital world. Furthermore, we have to take into account not the theoretical laboratory controlled situation that usually is encountered during research projects, but we have to take into account a real case scenario. In a real case scenario, when a digitally captured signature is disputed, the institute that has possession of the biometric data of the digital encrypted container file will probably decrypt the file themselves and provide access to the biometric data for the expert. So there are even more difficult steps that do not include the forensic expert before the expert can have access to the biometric files, to the biometric data. So let's look at the two scenarios that the forensic laboratory will have in order to deal with biometric data. So the first scenario is external source files. External source files can be digital files received as evidence, either in encrypted container files or extracted data. And as such evidence, it may include the disputed signature or known material. So, for example, in the bank scenario, the bank may give the expert the disputed signature biometric data, but also biometric data from other transactions of the customer so that the expert can perform the comparison. Then we have the intermediate analysis files, either copies for analysis or normalized data files, meaning that in order for the expert to perform the analysis, they might be handling the data and the numerical values. And then we have the report files, because in the end of the day, when the examination is complete, there needs to be a report. So the question here is, what type or which part of the biometric data is going to be included in that report or not. And finally, according to the laboratory nomenclature, we can have the archiving. The same goes for the other type of biometric data that can be encountered in a forensic laboratory environment, and that is the internal source files. In this case, we have digital files that are created from collected samples in case that we can have access to the writers involved in the case, and we can collect handwriting samples and specifically biometric data for the purposes of the comparison. So that is another source of biometric data. And again, that type of material follows the same route as the previous one presented in the previous slide. So we can have intermediate and analysis files, report files, and archiving. So we can see that biometrics are everywhere in the flow, in the workflow of a case that has to do with biometric data, either in the form of disputed signatures or in the form of known material. Xanthippi?
Hi, hello. I really can't see anything in the slide. Yeah, there you go. It's true, as Nico mentioned, the biometric data that is extracted from the digital capture signatures are everywhere. And this is not a bad thing. The digital capture signatures have dynamically entered our world and the forensic examination world, and they're here to stay. And since they are technologically advanced tools, the fact that they produce biometric data should not scare us just because the law, not just in the European Union, but in other parts of the world too, is very strict on how we use and process the biometric data extracted from those kind of signatures. These signatures are recognized legally in almost every legal regime around the world. But the biometric data extracted from it comes with a certain amount of protection because it is a special category data. I think we can move on to the next slide now. Because it is a special category of data that should be allowed more protection than regular personal data, because if they're used in another way than the subject of the personal data actually allows us to use them, we all understand how harmful this can be. So those signatures, as was mentioned, the digital capture ones are very different than other electronic signatures too, because they are human. And the biometric data they produce are not actually the regimes, the legal regimes around the world are very strict on the way that we are allowed to use them. So we're only allowed to use them for a very specific and a very good reason, and only under strict conditions. This is mostly, it's very precisely regulated in the European Union under the General Data Protection Regulation, the GDPR, as you may have heard, which is not the only data protection regime available. There are several other similar data protection regimes in North America, in South America, and they have similar aspects when it comes to biometric data. And the legal obligations when processing biometric data come not only for data controllers, but also for data processors. And in order to understand the role of a forensic examination laboratory or a forensic examiner in this situation and be able to place them correctly in this chain, in this legal chain, we have to know who is who. So moving on, let's see who is the data controller and who is the data processor. The question documents examiner or the laboratory and a private client. Let's just take an example for better understanding. So we have a private client, for example, it could be a bank or another institution that has an issue with a disputed digital capture signature, and they need to resolve this issue. So they will ask from a question documents examiner or a laboratory in a private way to examine the biometric data produced by this kind of, I'm sorry, I lost my screen, from this kind of signature. And in this case, the bank, the private client, is a data controller because they already have collected those biometric data and probably already have decrypted them in a file, if they are allowed to, from the data subject. And they are the laboratory, the examiner is the data processor, the one that will have to do the actual processing on that biometric data. And this can only happen by using a data processing agreement between those two, because a data processing agreement actually has specific clauses that cover issues that are very, very important for the protection of those special category data, like the location where the data is going to be processed, the controlled environment that the examiner and the laboratory must hold in order to carry out the processing in a lawful way, and the encryption and who will hold the key, who will be able to decrypt and access the data at all times. This is something that should be laid out very specifically. The security measures and other technological measures that come with those data, and the retention period. For example, the data processor cannot hold the data forever. They will actually go on with the processing and will be able to provide evidence at the end of the processing of what they did with this with those data. And these all come down to the notion of accountability, which is very specifically used in the GDPR, but also with the use of some similar words in other legal regimes too, because the ones that have access and process this kind of data should be able to provide all the evidence and all the documentation whenever the data subject asks for it and whenever the regulatory authorities ask for it as well. Just realizing that the legal regimes might be very strict on these issues, it doesn't mean that the use of the digital capture signatures is not beneficial for all parties involved, because both the data controllers and the data processors, for example, the question document examiner or the laboratory will benefit from the use of these digital capture signatures. And so will the data controllers, but they all need to assure that the biometric data extracted from those digital capture signatures are not excessive, first of all. So as Nico mentioned, the series of numbers that we extract from those signatures must be very specific and not more than we have to have in order to process them, and will only contain the information required required for the specific purpose. And the purpose is to uniquely identify a person. So the information that comes from a digital capture signature to identify the signatory is the only one that should be allowed to enter that range of biometric data. So all these should be defined in a very specific way in the data processing agreements and the security measures and technical measures and all that. We could move forward. So having mentioned all that, someone would ask, come on, it's very tricky, it's impossible, it's very difficult. How can we have all these kinds of documentation? It's too difficult, so let's not use it at all. Is it even possible to lawfully process this kind of personal data? And yes, it is possible, but you have to follow specific rules. I mean, if you follow the rules and the clauses of the processing agreement and the best practice that is out there, because these legal regimes are not something that happened yesterday. They come from a long way back. So best practice is always there. And everyone is welcome to use it. So data controllers, for example, the ones that collect the data and they define the means and the purposes of the processing, like the bank in our previous example, they can follow best practice by avoiding processing for any other reasons than the one they collected them for. For example, they collected a digital capture signature for using it to prove that themselves and the signatory have entered into a deal, into an agreement, into a contract. So this is the reason they should actually use those. Can we go back for a while? Sorry. This is the reason and the purpose they should use the data for and keep it encrypted unless something happens. For example, someone disputes this kind of signature or any other reason that will have to do with its forensic examination. So they should offer data subjects with alternatives. And here comes some best practice solutions that involve hybrid solutions, the ones that actually involve the use of paper and the use of technological tools in order to sample this digital capture signature. And this is because they offer alternatives to the data subjects. And in case of any dispute, the paper is the one that can be actually used to carry on with the processing. And of course, when it comes to transferring and accessing the biometric data, and transferring to a data processor, all the measures of security and technical control should be there to ensure that there will be strong end-to-end encryption and exercise strict control on their data processor and their security measures. And as we mentioned before, define their retention periods and the processing clauses and the agreements. And of course, notify the data subjects on their rights on the spot of collection and use a processing activities book that actually describes every activity that's being done on this data. The data processors, on the other hand, the examiner or the laboratory should equip their lab with all those data protection policies and technical measures and risk management procedures to make sure that there will be no data breach or there will be any other issue with security. And of course, follow the processing agreement clauses. And if they have to collect any samples of digital capture signatures in an intermediate step of the process, of course, they will be obligated to inform the data subject on the spot and use verified forms and forms that have been agreed with the data controller in the first place. And of course, if the examination process requires storage of templates for using later comparisons in the process, there should be a specific process laid down and agreed with the data controller and is to be followed at all times. And of course, only process and store the data in the location defined in the agreement and have a controlled environment and security measures. And of course, use strong encryptions and follow the encryption instructions of the data controller. And in the end, for everybody, there is some best practice to be taken into account. And this means embedding the key processes of the GDPR or any other data protection regime in every step of the process. Have different and distinct databases for any processing that has to do with digital capture signatures, and distinguish between the biometrics and the hybrids and the pen and paper ones, so that you will be able to provide documentation of which has been accessed at all times and when it has been accessed. And collecting consent forms, informing the data subject. Of course, keeping encryption and key management policies, security policies, and security measures. And of course, the best practice for all parties involved in the processing of biometric data is laying out an impact assessment on the risks of collecting, storing, accessing, and analyzing those biometric data templates. And this should be able to give you a specific risk rate on those processing activities in case that something goes wrong, so that you will be able to comply with the obligations of accountability. And of course, the best way to go is outsource the data protection needs to privacy professionals, because they are the ones that will be able to help and address all those issues that are not just mostly legal, but are also technical. So I think this concludes my part.
Yes, and as Xanthippi mentioned, the use of hybrid solutions might be a good strategy to somehow avoid the intricacies of data protection and privacy requirements, or at least have a more viable solution as to that. But if there's something to be gained by this presentation and to get closely in mind both to forensic practitioners and forensic laboratory managers, is that the digital medium that includes digitally captured signatures has a different legal baggage, let's say, with respect to the pen and paper signatures, and therefore it should be treated with the appropriate considerations in order to reach the solution and not have such legal problems. So thank you very much for your attention. If you have any questions for this presentation, please let us know. If not, we can proceed with the second joint presentation with Ms. Poprelka. Okay,
so thank you. So both of you for the...
Thank you. I will be leaving you.
Yeah, ma'am.
Thank you.
Okay, so you will continue with the second one now.
Yes, I continue with Ms. Poprelka. So let me share the screen again. Just give me a moment. Okay. So, Katerina?
Yes, good morning, everyone. Thank you for having us here today. My name is Katerina Poprelka. I'm a licensed psychologist in Greece, and I'm studying clinical neuropsychology and cognitive neuroscience at National and Kapodistrian University of Athens.
And together, we are going to discuss the use of third-party electromagnetic resonance styli for digital capture signature execution. We will be covering the general aspect of using third-party devices in this type of hardware solutions, and we will be focusing on the Lamy All-Star Black EMR stylus. So, first of all, a small introduction. A few years back, Wacom decided to cooperate with third-party companies and provide with them the pressure sensor, which is the essential part of the circuitry. Just a moment. I'm having an issue with my PowerPoint. Just give me a moment. I need to do something because it keeps jumping slides. Just give me a moment. Let's see if this helps. Right. So a few years back, Wacom decided to share the pressure sensor that is the active part of the EMR stylus with other respectable companies in the pen and pencil manufacturing area. So, for example, we have the Mitsubishi Hi-Uni digital pencil, which use the same form factor as some of Mitsubishi's products, but has inside the necessary components for this stylus to be compatible with several EMR devices from Wacom. We have Stadler, which created the Stadler-Norris digital pencil in two forms, and again, we can recognize the form factor, which is the classic, typical Stadler pencil with the appropriate EMR sensor inside in order to work with these devices. And then we have the Lamy All-Star Black EMR. All of these devices, including the Lamy one, have the same Wacom EMR sensor. And according to our calibrations, is the same one that is used in the DTC and the DTU display EMR digitizers of Wacom. These devices are aimed mostly to designer purposes, but the use of these devices to more high-end applications and deployment in the banking and financing world is obvious. For example, bank that uses DS capturing with the tellers will also be using DCS technology when signing contracts. But when signing contracts, the equipment use and the layout needs to be more high-end, more lucrative to the customer. Another example is what has been happening in Russia. In January of this year, the Russian Notary Federation deployed a huge system and database of DCS solution in order to replace the pen and paper signing of contracts. So we can see a very high-end, a very expensive, let's say, transaction is being now carried out massively with DCS equipment and EMR technology. And it makes sense that they will opt for a more high-end and more natural-looking device rather than the default plastic stylus that is included with the digitizers. So these devices have a very wide range of compatibility with several devices. As they have not been focused on the forensic application, the list of devices available on both Wacom and Lamy websites is limited. Part of our research included an interoperability study, and we are in a position to confirm that these styli do work with the business Wacom digitizers like the STU530, the STU540, and the Wacom DTU. And we are in a discussion with Wacom, and we have let them know. So at some point, there will be an official update mentioning that these devices are compatible with more digitizers than the ones that are mentioned on the website officially. The other thing that was of interest for us from a forensic point of view and a practical point of view was the behavior of the signer, of the writer, when operating such a stylus versus the default stylus. And this is where we decided to construct an experiment in order to measure the satisfaction rating from the aspect of the writer. Katerina?
Thank you, Nico. I'm going to present the experimental design and the statistical analysis of our research to explore the use of the LAMI styli and the possibility of them being better than the default stylus, we conducted a research. 25 and counting volunteers signed 15 times, both with default and LAMI. After that, we asked our participants to answer a single question, whether they would buy their own EMR stylus to sign e-signatures on digitizers for legal transactions or not. We can move on. For the purpose of our study, we used a 5-point Likert scale. The 5 points were as follows. 1, strongly disagree, 2, disagree, 3, neither agree nor disagree, 4, agree, and 5, strongly agree. But why did we choose a Likert scale? Well, there are plenty of reasons. For example, the questions are quite consistent and clear in a Likert scale, in contrast to a semantic differential scale, in which subjects are quite prone to subjective interpretation. Also, we avoided to use a semantic differential scale because it is quite difficult to find the exact pair of adjectives. Next slide. We move on to our statistical analysis. As we can see on the first bar chart on the left, the vast majority of our sample are college graduates, and they are right-handed. We move on, can move on. Also, they reported they have no experience in signing on a pad with a stylus. And also, they mentioned they have signed 10 or less times on a pad. We can move on. Thank you. Now, this slide is quite interesting. As we can see from the pie chart, 80% of the participants chose the LAMI stylus with paper surface. Only 20% of our volunteers chose the LAMI stylus with glossy surface. LAMI stylus with glossy surface has more friction, and we assume it was made for graphic design purposes. LAMI All-Star EMR pen with paper surface is smoother, and that's why it's more convenient, more suitable to sign with it on a pad. Let's move on. Okay. Now, our statistical analysis of our data was performed with the assistance of SPSS software. The Kolmogorov-Smirnov test revealed that our sample did not follow the normal distribution, and that's why we used non-parametric tests. We performed a Wilcoxon matched pair sign ranks test to compare each LAMI stylus with the default stylus. Surprisingly, no statistical significant difference was found, and as we can see in the next slide, we had the subtle difference concerning the writing speed. As you can see below the last question, could you sign fast enough with a specific stylus? We had a subtle difference between the default stylus and the LAMI stylus. We can move on. Okay. One way ANOVA was used to compare LAMI All-Star EMR with paper surface and Lamy All-Star EMR with glossy surface. Our results revealed a statistically significant difference between the two Lamy styli regarding the comfort and the natural feeling of the styli in relation to an inking writing instrument. As you can see at the bar chart, the difference between the two Lamy styli concerning the comfort and the natural feeling are depicted quite clearly. The rest of the difference were quite subtle. Next slide, thank you. Now, after completing the questionnaire regarding experience with Lamy styli and the default stylus, we asked our participants to answer whether they would buy their own EMR stylus to sign a signature on digitizers for legal transactions or not. Again, we used the 5-point Likert scale. We performed a Spearman correlation to examine which variables from our questionnaire are related to the decision of buying an EMR stylus. We found a statistically significant correlation between the decision to buy an EMR stylus and the comfort, the natural feeling, the stable grip, the accuracy, and the writing speed. And in order to examine the relative contribution of each of the predictors to buying an EMR stylus, we perform a multiple regression. We include 5 out of 7 variables that were associated with the decision of buying an EMR stylus. The predictors of comfort, natural feeling, stable grip, accuracy, and writing speed explain 61% of the total variance. Well, it's not a huge percent, but significant. However, only the natural feeling was a statistically significant predictor. Also, accuracy approached the statistical significance, but eventually it wasn't significant. As we can see, the key to buy an EMR stylus is the natural feeling. However, I'd say we need more participants in order to reach a safer conclusion. Nico, you may continue with your presentation.
Thank you, Katerina. So we've seen how the writer perceives this new device. At the same time, having collected biometric data, we decided to look at the characteristics of that set of biometric data and compare them between the default stylus executed signatures and the Lamy pen executed signatures to see whether from the aspect of characteristics we had some noticeable difference. So when we approached the data, we decided to start the examination by looking at the average speed of execution, the total time of execution, and the stroke length of the signature formation per writer. Looking at these averages, we found that the average speed difference between the signatures executed with the default stylus and the signatures executed with the Lamy pens was at 9.25%. The average time difference was 9.20%, and the average stroke length was 12%. But when we looked closely to the largest differences per writer, we found writers who exhibited a maximum difference of the average speed of about 24.9%, which is quite significant. Maximum difference in total time of execution, 30.1%, and maximum difference in stroke length execution, 30.3%. So these are quite big differences between the two styles. So the next logical question is which one of the two styles is closer to the natural writing behavior with the pen and paper liquid ink instrument. So in order to examine that, we have started collecting samples, hybrid samples as well. As we've mentioned in the previous 2 lectures, the hybrid samples have the advantage of having the writer use a ballpoint with liquid ink pen executing their signature on a paper substrate, so it's completely natural, normal, and equivalent to the pen and paper signing behavior. But at the same time, we do collect biometric data. So we had a very limited run due to COVID restrictions and to the fact that we recently deployed the second phase of the experiment. We managed to collect samples from only 3 volunteers, including the hybrid version of their signatures. And these first results are very conflicting. So we have different relations between the different medium for the different average metrics per writer. So at the moment, we cannot make any suggestion, we cannot draw any conclusion regarding which type of stylus is closer to the pen and paper execution of signatures. This remains to be seen as soon as we have more samples from all 3 different types of signing behavior. So thank you very much again for your attention. If there are any questions, please, we are at your disposal.
Thank you, Nikolaos and Ms. Katerina.